All right, here we are with our second day of 1.1. So lines, points, graphing, a little bit of the distance formula. That's going to continue to be the focus here. I just want to talk briefly about how we would go about graphing a line. I'm going to use a very straightforward technique of just producing a brief little table of values. I'm going to pick a handful of x values. And when we're dealing with a line here, it's not really super important which x values we pick. I do want to point out here that depending on the kind of equation, it potentially can be. If we had a quadratic or a cubic or a rational function or an exponential, a lot of times a graph or an equation that has a curved graph that has a little bit more unique shape, to get a good sense of what that graph looks like, we potentially need to be specific about which x values we're going to take a look at to produce our sketch. With lines, we have a pretty decent sense of what it's going to look like. It's going to be either a horizontal, vertical, or diagonal line, either going up or going down. And whatever points we pick are probably going to give us a good sense of what the shape is. All right, so when I pick my x values, I plug those in and then simplify a little bit to get my y value. So in the first one, I put in -2, multiply that by 3, and then subtract 2. Okay, certainly feel free to check the arithmetic yourself. When you put in x equals -2, we get y equals -8. Put in -1, we get -5. Put in x equal to 0, the y value is -2. Put in x equals 1 and y is 2. And, excuse me here. Nope. Scratch that. Hold up here a minute. Hold up. How about 1? 1 seems much, much better. And 2, 4. Much better. That stays consistent with our slope of 3. All of those y values are increasing by 3. Now you'll see here, if I want to just plot the points and make a sketch, I can certainly do that. Notice the first point doesn't actually even fit. If I stick with a scale factor of 1, it doesn't fit. I could certainly change the scale factor, which I'm not going to do because that's just making this problem out to be a little bit more than what it is. I'll start with that next point. I can go 1 over and 5 down. Okay. I can do 0, -2. I can do 1, 1. Excuse my writing here. My pen is a little bit difficult to make nice points, but it can't stop me from illustrating my point, no pun intended, that the points form a line, you can connect them, and you've got your graph, and it's wonderful. Wonderful. All right, that's the basics of producing a sketch of a line. What if we wanted to produce a graph by checking some axes intercepts? There's an intriguing way to do it. Remember, to actually make the sketch, I produced a table with 5 points. Theoretically, all I needed to produce was 2 and then connect them. So what if I wanted to take this line in general form and then just find the x-intercept? Okay. Remember, the x-intercept occurs when y is 0. Okay. So that means I could put in, let's see, 3x plus 2 times 0 equals 18. That's going to cancel beautifully from multiplying by 0. 3x equals 18. Well, that's not a horrific equation to solve. That means that x has got to be 6. That wasn't too bad. That wasn't too bad at all. Now for the y-intercept, this is going to occur when x is 0. So let's basically repeat the process, except let's put in 0 for x That cancels, and once again, I'm left with a very reasonable equation to solve. Y equals 9. So I know this graph goes through the point 60. It also goes through the point 0.9. And that happens to be plenty of information to make my sketch. Okay, once again, excuse my graphing here. I'm doing the best I can. All right, and there I could connect those 2 points. That's much better. All right, same idea. All right, you really just need 2 points, but a variety of different ways to go about graphing. All right. Alrighty here, working backwards with the distance formula. All right, got an interesting little problem to take a peek at here. I've got these 2 coordinates P and R that I know are 17 units apart. I'll refer to my distance formula here, 17 units apart. I know the coordinates of R, and I know the x coordinate of P is 5. So I'll make note of that up here, that P is 5, comma, Y. Okay. I'm going to set up my distance formula here, starting with my x values, which would be 5 minus -3. Always be mindful of your negatives. And with my y's, it would be, let's see here, if I did 5 minus -3, it should be y minus 2. Okay, notice I have a single equation, I have a single variable. That means this thing is solvable. Okay, it can be solved, it's not going to be the most straightforward equation. This whole mess at the beginning of 5 minus -3 squared, that's 64. Feel free to pause and look through that arithmetic if you need a little more justification than my word for it. Feel free. All right, the next step here would be to square. Now, one element of this problem I haven't even really mentioned yet is the instruction said there will be 2 possible right answers for this y coordinate. That's kind of interesting. I'm not exactly seeing how this is going to yield 2 answers yet, but I'm open to it. We'll see when we get there. All right, 225 equals y minus 2 squared. Here's where things get interesting. I'm going to take the square root of both sides, and that just leaves me with y minus 2 on the right, and the square root of 225 is 15. Positive or negative 15. Okay, a square root can yield 2 different answers. And here is where we get our 2 possible answers. To finish this thing off and solve it, I'd have to take 15 and add 2. That means one of my possible right answers would be a y coordinate of 17. And I have to take negative 15 and add 2. It could also be negative 13. So either one of those y coordinates for P would give it a distance of 17 units from R, okay, which is at this location here. All right, so there's more the distance formula can do than just calculate distance. This is obviously based on distance, but we can work backwards and kind of do some creative things. Okay, it takes a little bit extra solving, but good problem solving, good algebra, good practice. All right, for this lesson 1.1 part B, we're going to call it quits there, and we will see you next time with 1.2.